Hey folks, today we are going to be doing a lesson on right bisectors, medians, and altitudes, which primarily are things that you can do with triangles, but you will also see how you can take care of things to do with quadrilaterals when dealing with this sort of thing. This is going to be a bit of a long lesson, so I apologize in advance, and hopefully you can just stick through here. First things first, we're going to talk about our right bisector. So our right bisector passes through the midpoint of one side of our triangle. It also is perpendicular to that side. If I were to go and add a perpendicular or a right bisector, either or, to this triangle, I have the triangle pre-drawn here, let's say with sides A, B, and C, and I've already found my midpoint of side BC, which is M. So my right bisector is going to be passing through M, and it needs to be perpendicular to side BC. So it is going to look approximately like this. That is my right bisector. Okay. Next, let's talk about the median. So the median of your triangle, it passes through one vertex, okay? So it's hitting a vertex. And it is also passing through the midpoint of the opposite side of the vertex. So it's going to be, the characteristics here are that it passes through 2 points. It passes through the vertex, and it passes through the midpoint of the side opposite the vertex. Okay, so let's just move down to my other triangle here, okay? So we had our right bisector that passed through the midpoint. Now our median passes through vertex, so I'm going to say it passes through A, and it also has to pass through the midpoint. So it is going to look like this. That is our median. And finally, we also want to talk about the altitude of our triangle, which we can also refer to as the height, but the proper term is altitude. The altitude passes through a vertex. And it is perpendicular to the opposite side. Okay, very similar wording to what we were dealing with the right bisector. A right bisector was also perpendicular to that side, except the right bisector passed through the midpoint, whereas the altitude passed through the vertex. And if I want to go ahead and add altitude to my triangle here, so the altitude, let's say it's going to pass through vertex A, and it's just going to come straight down. The altitude is by far the easiest one for students to remember, because it is the height of the triangle. If you think that's what you were used to seeing when you were finding the height of your triangle. That is the altitude. And now, if this was a basic geometry class, we would be done here. But we are talking about analytical geometry. And so we need to find the equations of these lines. We need to find the distance of these lines. And so far, you have everything that you need in this course to be able to do that. It's just about thinking about it in this new way. Let's consider our altitude first and foremost, okay? The altitude here, remember it's passing through a vertex and it is perpendicular to side BC. In order to find the equation of the altitude, remember every time you find an equation of a line, you need a slope and you need a point. Passes through the vertex, well, that is the point. and it is perpendicular to the opposite side of the vertex. It is perpendicular to side BC, which means I need to find the slope of side BC and then find the negative reciprocal so that I can find the slope of my altitude. So in order to find my equation, I need a point and I need the slope of BC. Okay, and these together will give me my equation, well, the negative reciprocal. Let's look at the median here. The median passes through the vertex and through the midpoint, okay? If we actually sit down and think about this, all we're looking for is a line that passes through 2 points, point M and point A. We've already seen that in this course. You even saw it last year in grade 9. Not that bad. We have point M, point A. We can find the equation of that line. I'm just going to write here, find the equation of a line between A and M. That's pretty straightforward. It's just between 2 points. That'll give you your point, because you can either use A or M, and it will also give you the slope. But you can do the whole thing in one go if you would like. Let's talk about the right bisector. Remember, the right bisector passes through the midpoint of one side. There's your point. It needs to be perpendicular to that side. Awesome. Okay, so now we need to find our slope of BC, and again, take the negative reciprocal. These things together will give you your equation. Okay? This diagram is really helpful to remember so that you remember what each term is talking about, and so you can kind of keep things straight. We're going to do one super long example here that's bringing into play finding the equations of these 3 things, but also finding the lengths and some other things that you can do with that information. Okay, given the triangle with vertices A at 3, 4, B at -5, 2, and C at 1, -4. Okay, these are our vertices here. This is the information that we need to remember. Okay, I'm just going to highlight these. The first thing that we're going to do is determine the equation of the right bisector of AB. Remember, the right bisector passed through the midpoint and was perpendicular to that line. So first things first, let's find the midpoint. The midpoint is exactly halfway between A and B, so the x value of my midpoint is going to be 3 minus 5 over 2. 3 minus 5 is -2, divided by 2 is -1. My y value will be 4 plus 2 divided by 2. 4 plus 2 is 6, divided by 2 is 3. My midpoint is located at -1, 3. That's the point that my line needs to pass through. Okay, now I need to find the slope between A, B. Step number 2, find slope. Okay, we're going to find slope using the slope formula. y2 minus y1 over x2 minus x1. B is going to be 2, A is going to be 1, so this is 2 minus 4 over -5 minus 3. 2 minus 4 is -2. -5 minus 3 is -8. My slope can be reduced to 1 over 4. However, I need the negative reciprocal here because it needs to be perpendicular to this slope. Okay? So I'm going to say the negative reciprocal is then going to be -4. So I have my two pieces of the puzzle. I have my point, I have my slope. Okay? Now we can find the equation of the line. You can do this any way that you would like. I'm going to do it the way that we saw this year, where I say that slope, -4, is equal to 3 minus y over -1 minus x. I'm going to cross multiply. -4 times -1 minus x is equal to 3 minus y. I use my distributive property here. -4 times -1 is 4. -4 times -x is positive 4x is 3 minus y. We're going to bring this all together into standard form here. 4x plus y plus 4 minus 3 is 0. And I can simplify. 4x plus y plus 1 is equal to 0. Now, because the question did not ask for a specific form of the equation, I could pick if I prefer doing standard form or if I prefer doing slope y-intercept form. It does not matter unless the question specifies, but to be very honest with you, we're not going to specify because that's just creating far too much work for you. Okay, so this is the equation right here of my right bisector of AB. Just put a little square around that. Okay, let's do another example. Determine the equation of the median from point C. Remember, the median was the one that was connecting the vertex to the midpoint of the opposite side. I have my vertex. Point C is the vertex that I'm looking for, and I'm just going to rewrite it. My vertex is at 1, -4. I also found my midpoint of my opposite side. My opposite side is side AB. The midpoint I just found in the last question, so I'm not going to do that again. It's at -1, 3. We need to determine the equation of the line between these 2 points. Okay? It is totally up to you how you want to do this. I'm going to do this the grade 9 way. Okay? First and foremost, I'm going to find the slope of the line. So my slope is going to be y2 minus y1 over x2 minus x1. That's going to be 3 plus 4 over -1 minus 1. It becomes a plus because it's 3 minus -4, so it's just positive 4. And then -1 minus 1. 3 plus 4 is 7, -1 minus 1 is -2. So my slope here is 7 over -2, and that was the formula from grade 9. Now I can go ahead and I can find the equation, and I can use either one of these points as the point I would like to use because I know the line has to pass through both of them, and this is the slope that's going to get me there. Okay? I'm going to find it in standard form because I find that the fastest way to do things. My slope, -7 over 2, is going to be equal to, and I'll pick the vertex here, -4 minus y over 1 minus x. I'm going to cross multiply. -7 times 1 minus x is equal to 2 times -4 minus y. I use my distributive property. -7 plus 7x is equal to -8 minus 2y. I move everything over to the left-hand side, so a 7x plus 2y minus 7 plus 8 is 0. And I can go ahead and simplify to put this in standard form. 7x plus 2y plus 1 is 0. And there is the equation of my median from point C. So it is point C to the midpoint of the line AB. Okay, so we found the right bisector. We have also found the median. Let's go ahead now and let's determine the equation of the altitude from point C. Remember, the altitude was the height of our triangle. So it needed to pass through the point. Okay, it needed to pass through our vertex, and that is located at 1, -4. and it also needed to be perpendicular to the opposite side. Okay, recall we have already done that with our right bisector. We already found the perpendicular slope. The slope was -4. So I already have this information that I can use once again. The slope of my line is -4. And now this is easy. This is just like a question from before, from previous units where you have a slope, you have a point. Let's find the equation of the line. I'm going to go ahead and do this. I have -4 is equal to -4 minus y over 1 minus x. Cross multiply. -4 times 1 minus x is equal to -4 minus y. Use distributive property here to give me -4 plus 4x is -4 minus y. 4x plus y minus 4 plus 4 is equal to 0. And I can collect my like terms here. 4x plus y. I have a -4 and a +4 that cancel out, so it's just equal to 0. And there's the equation of my altitude from point C. Now that we've got some equations, we can also go a little bit further and really put into practice our understanding of the distance formula. Okay, so let's get started with this question. I have point C. Point C is 1, -4. Okay? And as I said, I need to find where the altitude intersects AB. So first, I need to find my equation of AB. Well, to find the equation of any line, as we've seen 100 times over, we need a point and we need the slope. We already found the slope in our very first question, determining the right bisector of AB. The slope of AB is 1/4. We also know that it passes through both A and B, A being 3/4. So that's what I'm going to use. I'm going to use my point A and my slope 1/4. So my slope, I'll just write it here, my slope is 1/4 and it has to be through 3/4. Okay, let's go about this. My slope is 1/4, so 1/4 is equal to 4 minus y over 3 minus x. Cross multiply. 3 minus x is equal to 4 times 4 minus y. I can expand. 3 minus x is equal to 16 minus 4y. I rearrange. -x plus 4y plus 3 minus 16 is 0. I'm going to collect my like terms here. -x plus 4y minus 13 is 0. Now, I know that standard form typically has a positive value in front of x. That is good standard form. But the point of this question was not to find the equation of AB. The point is we are needing to find where the altitude intersects AB. So I just need an equation for line AB. I don't need the perfect equation for line AB. The formatting does not matter here. What matters is figuring out where this equation, which is my equation for AB, intersects the equation for my altitude. To find the point of intersection, I need to solve. Okay, I need to solve, and I'm going to solve by elimination. So I have 4x plus y is 0, and I also have -x plus 4y minus 13 is equal to 0. Okay, what I'm going to do is I'm going to multiply my first equation by 4, and that way I can cancel out my y's. So this is going to become multiply the top equation by 4. And this is going to become 16x plus 4y is 0. and then negative x plus 4y minus 13 is equal to 0. And I can go ahead and subtract. Okay, 16 minus negative x gives me 17x. 4y minus 4y is just 0. And 0 minus negative 13 is going to give me positive 13 is equal to 0. And I can rearrange this. Unfortunately, it does not come out very nice. X is equal to negative 13 over 17. In order to find y, I'm going to plug this number back into my first equation. 4 times negative 13 over 17 plus y is 0. That's negative 52 over 17 plus y is equal to 0. So y is equal to 52 over 17. My point of intersection, therefore, is at the point negative 13 over 17, 52 over 17. This is not a pretty point, but that's okay. Remember, the whole point of this question was to figure out the height of the triangle, okay? I have one point here. That is the vertex of my triangle. I have now found where my altitude intersects my opposite side. So I have just found, let's go back to our diagram here. I have just found this point right here. I have found where the altitude is hitting my opposite side. All we need to do now is find the length or the distance between those 2 points. Remember that the distance or length is equal to the square root of the difference between the x values. So I'm going to do negative 13 over 17 minus 1 squared plus the difference between the y values. So this is going to be 52 over 17 plus 4, because it's minus a negative, and again, all squared. Okay, this is not going to end up being a very nice number, but we can do what we can do. Okay, negative 13 over 17 minus 1. We're going to go negative, we're going to change the 1 to be a 17 over 17. So I have negative 13 minus 17 is going to be equal to negative 30. So this is negative 30 over 17 squared plus, and then I have 52 over 17 plus 4. 4 is the same thing as 68 over 17. And then I add 52, so this gives me 120 over 17, also all squared. Okay. Remember, when you square a fraction, you have to square the top and the bottom. So this is going to be the square root of 300 over 289 plus 14,400 over 289. And so this is the square root of 14,700 over 289. And we can go ahead and approximate that to be about 7.13. So the altitude of my triangle, it took a lot of work to get there, is 7.13. Okay, recall, we needed to find the height of the triangle. In order to find the height of the triangle, I need to determine the distance between C, which was the vertex, and where my altitude intersects AB. That was the opposite side. I needed to find the equation of AB so that I could figure out where that equation intersected the equation of the altitude. Okay, so I needed to find the equation of AB, and that's what I'm doing here. That was my equation at the end of the day. I needed to find my point of intersection then between AB and between the altitude. Okay, the point of intersection I solved by elimination. I found my point of intersection here. And then I needed to find the distance or the length between the point of intersection and C. So I used my length formula. Okay, it is a strenuous process. No one is suggesting that it is not long and complicated, but it is not actually that difficult to do because you have all of the tools that you need. Let's do 2 more examples. Determine the area of the triangle. Okay, that's not so bad. We have already found the height of the triangle. Remember, in order to find the area of the triangle, we need the base times the height divided by 2. And I just found the height. My height is approximately 7.13. Now I just need to find the base. Well, the base in my triangle is the distance between those 2 vertexes AB. So I need to find the distance between AB. Okay, that's pretty easy to do. This is just a distance formula question. My AB points were 3, 4, and -5, 2. So I need to find the distance between those. Let's go ahead and do that. The distance is going to be the square root of -5 minus 3 squared plus 2 minus 4 squared. This is the square root of -8 squared plus the -2 squared. That's 64 plus 4, which will be the square root of 68. And the square root of 68 is approximately 8.25. I have my base, I have my height. I can go ahead and solve for area. Area is equal to base times height divided by 2. So this is going to be 8.25 times 7.13 divided by 2. 8.25 times 7.13 is about 58.82 divided by 2. And that is roughly 29.41 units squared. We don't know what the units are, so we're just going to leave it as units. That was a pretty easy problem because we already had the height of the triangle from the previous question. All we needed to do was find the base, and then we were able to calculate the area using the formula for area of a triangle. Let's look at our very last example here. Determine what kind of triangle we are dealing with here. There are 3 types of triangles, as we can recall. We have an equilateral, we have an isosceles, and we have a scalene triangle. We are dealing with one of them. In order to find what kind of triangle it is, I need to find the lengths of the 3 sides. So I need to find AB, BC, and AC. Well, I just found the length of AB in my previous question, so I'm going to go ahead and snipe that. That's approximately 8.25. So the length of AB is about 8.25. All I need to do now is find the distance between BC and find the distance between AC. Okay, so the length of BC is equal to the square root Point B is located at -5, 2, and point C is located at 1, -4. So I'm just going to write down that C is at 1, -4, okay, because I have B on my top of my sheet here. So from point BC, I'm going to go the difference between my x's, so I'm going to go 1 plus 5, because otherwise it would be subtracting -5 squared, plus -4 minus 2, all squared. 1 plus 5 is 6, so this is 6 squared. -4 minus 2 is -6 squared. Go. This is going to be the square root of 36 plus 36, which is the square root of 72. The square root of 72 is approximately 8.49. Okay, so I can already rule out that this is not an equilateral triangle because the length of BC is 8.49. It's pretty close though. I now can find the length of AC. The length of AC is going to be the difference in x values, difference in y values, just like usual. So this time I'm going to do A minus C. I'm going to do 3 minus 1 squared plus 4 squared, again because it's subtracting a -4. 3 minus 1 is 2. 4 plus 4 is 8. This is going to be the square root of 4 plus 64, which is the square root of 68. Square root of 68 is about 8.25, and we have ourselves an isosceles triangle. Because side length AC and side length AB are the exact same length, we know that this is an isosceles triangle. So I can conclude, write a little therefore statement. Therefore, this is an isosceles triangle. And that's it, folks. So all you really need to do is it's just going to be lots of practice working with these different types of tools, these different strategies, finding the distance, finding the midpoint, finding equations, solving equations, bringing them together, okay? It takes a lot of practice, it takes a lot of massaging, a lot of manipulating. Once you get the hang of it, once you kind of get that muscle memory going, it's really not going to be that bad. I would suggest that you keep a page like this, the very first page of the note here, kind of in front of you as a reminder for what these terms mean, what they give you, and what you need to find the equation, as well as some kind of a diagram, just to kind of keep everything straight. If you're having challenges with finding the equations, like we just did where we found the equation of the right bisector, the median, and the altitude, if you're struggling to find those types of equations, then I would strongly suggest that you go and you review everything that we were doing at the end of Unit 2, where you had to find the equation in standard form of the line, okay? And that's it. Have a great day.